Let us look at proposition number 17 of book 13 of Euclid's Elements. The proposition says to construct a dodecahedron and comprehend it in a sphere, like the aforesaid figures, and to prove that the square on the side of the dodecahedron is the irrational straight line called apotome. So here we have to inscribe a dodecahedron inside a given sphere. So let's start. Let ABCD and CBEF be two planes of the cube at right angles to one another. Now, how to construct a cube we have already seen in one of our previous propositions inside a sphere. So basically we are taking two planes of that cube. Bisect the sides AB, BC, CD, AD, EF, EB, and FC. Join GK, HL, NO, and MH. And let's mark the points of intersection of these lines as Q and P. Cut NP and PO and HQ in extreme and mean ratio at RST. So here PO has been cut at S in extreme and mean ratio such that PS is the greater segment. P has been cut at R in extreme and mean ratio such that RP is the greater segment. Again, HQ has been cut at T in extreme and mean ratio such that QT is the greater segment. Now RP, PS and TQ are the greater segments. Set up RU, SV perpendicular to the plane BCFE and TW perpendicular to the plane ABCD. Now join UB, PW, WC, CV, UV. Next, we join RB, SB, and VB. PN square plus NR square is equal to 3 times RP square. Since NP has been cut at R in extreme and mean ratio, PN is equal to NB because BHPN is a square. RP is equal to RU. So we take this and do the necessary substitutions so that this becomes NP square plus NR square is equal to 3 times RP square. BR square is equal to NB square plus NR square because that's a right angle. So NB square plus NR square is here. So we again do the substitution and say BR square is equal to 3 times RU square because again RU is equal to RP. Now let's add RU square to both the sides. So here we have BR square plus RU square is equal to 4 times RU square. But BR square plus RU square is equal to BU square since BRU is a right angle triangle. So which means we can say BU square is equal to BR square plus RU square. So BU square is equal to 4 times RU square. If we take the square root, we get BU is equal to 2 times RU. Now VU is equal to 2 times UR because Rp is equal to Ru, Ps is equal to Sv. So if we take the midpoint of UV, it will be perpendicular to the plane BCEF from P. So that means VU is equal to 2 times UR, since SR is equal to 2 times PR. So BU is equal to UV, since both BU and VU are 2 times RU. Similarly, we can show that BW is equal to WC is equal to CV is equal to BU and is equal to U. That is, all the sides of this figure is equal. And this figure is a pentagon. So pentagon BUVCW is equilateral. Now, HQ is cut in extreme and mean ratio at T, and QT is its greater segment. That means we can write this proportion HQ is to QT is equal to QT is to HT. Now, HQ is equal to HP and QT is equal to TW, which is also equal to PX. So we draw a perpendicular from P to the line segment UV. So TW will also be equal to PX. HP is to PX as WT is to HT. This proportion after substitution becomes this. So that means HP is parallel to TW. Since HP and TW are perpendicular to the plane BD, one to this side and one to the other side. Now, again, TH is parallel to PX. Again, since TH and PX are perpendicular to the plane BF, one to this side, one to the other side. So, triangle XPH. So, let's join X and H, and let's join H and W. So here, if you notice, these two triangles XPH and HTW are side by side at the same angle, and corresponding sides are parallel. So that means XH and HW are in a straight line. So every line in pentagon BUVCW is in one plane. So that means BUVCW pentagon is in one plane. Okay, so what have we done? We have shown that the constructed pentagon is equilateral and this pentagon lies in one plane. So these two things we have shown. Now, NP is cut in extreme and mean ratio at R. NS is also cut in extreme and mean ratio at P, and NP is the greater segment. So that means the square on NS plus the square on SP is equal to 3 times NP square. And NP is equal to NB and PS is equal to SV. So NS square plus SP square is equal to 3 times NB square. Now let's add NB square to both the sides. We get NS square plus SV square plus NB square is equal to 4 times NB square. Now, SB square SB square is equal to what? Is equal to NS square plus NB square. Because the triangle NBS is a right angle triangle. SB square plus SB square is equal to BB square, because triangle BSV is a right angle triangle. So NS square plus NB square is equal to SB square, and SB square plus SV square is equal to BV square. So we can say BV square is equal to 4 times NB square. And if we take the square root, then we have BV is equal to 2 times NB. Since BC is equal to 2 times NB, implies BB is equal to BC. Triangle BUV triangle is equal to triangle BWC. Why? Because BV is equal to BC. Yes. And we have seen that BW is equal to BU. UV is equal to WC. So that means these two triangles are equal, which implies angle BUV is equal to angle BWC. Similarly, we can show that angle UVC is equal to BWC. And since three angles are equal, pentagon BUVCW is equiangular. So we have constructed a pentagon on BC, which is equilateral and equiangular, and it lies in one plane. Pentagon BUVCW is on the edge of the cube BC. Similarly, we construct pentagons on the other 11 edges of the cube. So that means we have a solid which is made up of 12 equilateral equiangular pentagons, each of them lying in one plane. Let me just show you the completed dodecahedron. So here you will notice this is the one which we constructed, BUVCW. And as we construct equilateral equiangular pentagons on the other edges, our dodecahedron comes into picture. So if you notice, this is a pentagon, this is a pentagon, this is a pentagon, this is a pentagon. So that is how it would look like. Now we have to visualize this dodecahedron inside the given sphere. So let's proceed with that part. Draw the diameter of the cube DE. So let's join DE. Now extend XP to Z, the intersection of XP and the diameter. So we draw a perpendicular line and we take the intersection of this line with the diameter DE. Here Z is the intersection. And now let's make this disappear. The diameter and XP bisect each other. So that means XZ cuts DE into two equal parts. And similarly, DE, remember, PZ has not been drawn to the other till the other face of the cube. We have only drawn half of it. So if we had drawn it to the other side of the cube, then DE would have bisected that straight line from P to the other side of the cube. Now, Z is the center of the sphere in which the cube is described. We know that ZP is equal to half of the edge of the cube. Edge of the cube is BC or BA or DC, any one side of the cube. join UZ, since NS is cut in extreme and mean ratio at P, and NP is the greater segment. That means NS square plus SP square is equal to 3 times NP square. NS is equal to XZ, since NP is equal to PZ and XP is equal to PS. PS is equal to XU, since PS is equal to RP. We have already seen this. So now ZX square plus XU square is equal to 3 times NP square by doing the necessary substitutions. Now UZ square is equal to ZX square plus XU square. Or actually we should be looking at it the other way around. Since we already looked at ZX square plus XU square, what is that equal to? That is equal to UZ square. So we can say now that UZ square is equal to 3 times NP square. Diameter of the sphere square is equal to 3 times side of the cube square. This we have already seen when we were discussing cube. Can also be written as radius of the sphere square is equal to 3 times half the side of the cube square. NP is half the side of the cube. So that means UZ is the radius of the sphere and Z is the center of the sphere and U is on the surface of the sphere. Similarly, all the other vertices of the dodecahedron lies on the surface of the sphere. That means we can draw the sphere now, because we know the radius of the sphere, we know the center of the sphere, and we know U is on the surface of the sphere. So let's do that. So U is on the surface, B is on the surface, A is on the surface, D is on the surface, F is on the surface, W is on the surface, C is on the surface. So we have visualized this dodecahedron in the sphere. So let me do one more thing. Let's put the dodecahedron and now let's draw the sphere as well. Okay, you got the idea. What do we have to prove? We have to prove that the side of the dodecahedron is an apotome. So for that, let's proceed. NP is to PR as PR is to NR, and PO is to PS as PS is to SO, because they both have been cut in extreme and mean ratio. Now, NP plus PO is to PR plus PS is equal to PR plus PS is to NR plus SO. What do we end up with? NP plus PO is NO. PR plus PS is equal to RS. Equal to PR plus PS is equal to RS. And this we can't write directly because it is split. NR we have it here and SO we have it here. So we leave it as it is. So we end up with NO is to RS as RS is to NR plus SO. Now, since NO is greater than RS, NO is greater than RS, implies RS is also greater than NR plus SO. NO is cut in extreme and mean ratio and RS is the greater segment. But we know that RS is equal to UV. So we can say NO is cut in extreme and mean ratio and UV is the greater sector. Diameter of the sphere is rational. The diameter is nothing but 2 times UZ, because UZ is the radius of the sphere. So 2 times UZ square is equal to 3 times side of the cube square. NO being the side of the cube is rational. And we know if a rational line NO is cut in extreme and mean ratio, each of the segments, that is RS and NR plus SO, is an irrational apotome. So UV being a side of the dodecahedron is an irrational apotome since RS is equal to UV. So we have shown how to construct a dodecahedron made up of 12 equilateral equiangular pentagons and each pentagon lying in the same plane, and how this dodecahedron can be visualized in a given sphere. And we have shown that the side of the dodecahedron is an irrational straight line called an apotome. So that is proposition number 17 of book 13 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.